Welcome to the Algebra 2 skill video for Unit 9, Skill 86. I can write and graph piecewise functions to describe real-world situations. A piecewise function is a function that is a combination of one or more functions, and we'll typically be seeing them when it's more than one function. So what we have here is f of x is our piecewise, and we have the first piece where it's equal to negative x if x is less than negative 1, or it's equal to 2x plus 1 if x is between negative 1 and positive 1, or finally the last piece, 2, if x is greater than 1. And we want to be able to do a couple things with piecewise functions. We should be able to look at the function and graph that function. So what I will do for graphing it is I'll look at the first piece, and the first piece is when x is less than negative 1. So really I only want to be looking over from negative 1 on. I'm going to put these dashed lines here, but they don't actually exist as part of the graph, so please don't include that. So this is our first piece on this section here, and we graph negative x, which means we have a negative slope, down 1 over 1, down 1 over 1, and the y-intercept would have been 0 if we included it, but we stopped at a value of x equals negative 1. Our second graph is 2x plus 1, and we graph that from negative 1 to positive 1. And so the y-intercept is 1, and we have the slope of 2, so we go up 2 over 1, up 2 over 1, and down 2 over 1. And notice that what I do is I put an open circle when it is at negative 1, and I go up to a closed circle when it's at positive 1, because that piece includes a positive 1 value. And finally, the third piece is f of x equals 2, and that's just a straight horizontal line at 2, and it has an open circle at 1. Not all piecewise functions have 3 pieces. Some of them have more, some have only 2. We'll typically be looking at 2 and 3 piecewise functions. Not only do we want to know how to graph the piecewise function, as we just did, but we should also be able to evaluate a piecewise function. And the process of evaluating a piecewise function is very similar to evaluating any function. If I want to know f of negative 2, I plug negative 2 into the equation. So I go up to our equation, except I have to pick one of my 3 pieces. And since negative 2 is in this section, I'm going to pick negative x. So negative 2 is equal to positive 2. When I want to evaluate f of 1, I pick which one of these 3 pieces it fits into, and it fits into the second piece because that's where 1 is included, and I evaluate 2 times 1 plus 1. That gives me a value of 3. And then finally I want to evaluate f of 4, and 4 is contained in the third piece. So I plug 4 in for any place I have an x, and in this piece I don't have an x, so it's always equal to 2. And the last part of a skill is we should be able to look at a graph and generate a piecewise function. And I've broken this up into 3 steps. Some people will combine steps 1 and 2 and just do it all in one go. But step 1 is define the pieces with our domain boundaries. So our first piece goes from negative infinity to 0, or you could say our left piece is when x is less than 0. Left. Our middle piece is going to be from 0 to 2, because it's solid dots on the end, we know we include 0 and 2 on that. And then finally, our right piece is from 2 on. So there we go there. The next thing we want to do is generate equations for each piece. So when we look at the left piece, the graph looks like a horizontal line at 3. So our equation for the left piece is just y equals 3. The middle piece looks like a parabola that starts at 0, 0, and out 1, out 1, up 3. So it just looks like the parent function of the parabola. So y equals x squared. And the final piece is actually a little bit harder to determine, but we can see it's down 1 over 1. So it's probably a negative sloping line. And if we were to continue that right piece, we'd go up along and we'd find that the y-intercept would have been at 4. So we have negative x plus 4. And then finally we want to match our boundaries with our equations. So our first boundary, x is less than 0, is y equals 3. So f of x equals 3 if x is less than 0. And then we combine the middle, x squared, with 0 is less than x, less than or equal to x is less than or equal to 2. And then finally the right equation is negative x plus 4 if x is greater than 2. Piecewise functions are often used to represent real-world situations. For example, a worker earns $8 an hour for the first 40 hours in a week, and after 40 hours the worker is paid $12 an hour. So our two pieces are the piece where he's working from 0 to 40 hours, and then the second piece is if he's working more than 40 hours. And if you can picture this as a graph, he starts at $0 for 0 hours, and as he goes up all the way to 40 hours, he goes up 8 over 1, up 8 over 1. So that's the slope on that line. And then at 40 hours, suddenly it's going to be a much steeper line because he's going up $12 for every 1 hour. So our equation for the first piece is going to be 8x, because we're rising 8, running 1. And then the equation for the second piece is going to be 12x, but we have to figure out the y-intercept. And that might take a while to go down here and graph, so there's other means for finding it. I'll leave the problem of solving that to the spectator. Basically, you're going to find where this equation and this equation are equal. So when does 8x equal 12x plus some number? And finding out what that number is, such that when x is 40, they're the same value. So 8 times 40 equals 12 times 40 plus some number. And that number happens to be negative 160. Alright, so the key idea and concept for this skill is a piecewise function, and we need to be able to identify a piecewise function. And it's not just something like that. It also has the constraints of if x is less than 0, if x is greater than or equal to 0. And we should be able to look at a function and graph it. So in this case, f of x is x squared minus 3, so that's a shift down for 3. And then it's an open circle at 0. And the second piece is x plus 5, so it shifts up 5 and has a slope of 1, and that's going to be a closed circle. We should also be able to evaluate the function. For example, f of negative 1. In this case, f of negative 1 will belong to our first group, and we get an answer of -2. And f of 0 belongs to our second piece, and that's 5. Or if we go to f of 1, that's definitely in our second piece, and that's a value of 6. And then finally, we should also be able to do the reverse. Look at a graph and generate the equation from it. Thank you.